Hello everyone, welcome to Math 1650D Pre-Calculus again. The purpose of this video and many others to follow is to provide supplementary lessons supplementary to the classroom lectures delivered on schedule. I noticed that a lot of students were having difficulty attending classes regularly. Either that's because having a full-time job somewhere, or due to their children, or whatever issues, whatever personal problems like medical problems and things like those. There are a variety of students who need supplementary lessons, I found. That's what I'm doing here. Of course, I do not want to follow the textbook with all those verbose details. What I'm going to do is to use my lecture notes and then deliver skeletons of ideas. Okay, let's begin with preliminaries, which is actually covered in chapter 1 of the textbook. Let's begin with some algebraic preliminaries. And the first one is a set notation. I believe everybody should know the set notation. Begin with brace, end with brace, and then we just have list of items there, which we call elements. And if we have pattern, then dot dot dots are okay. Or you can represent a set using a set builder notation, kind of like this. Actually, this is a naive version of set builder. The precise version of set builder notation must begin with a set known a priori, kind of like x, which is, excuse me, not here, here, x that belongs to the set of natural numbers, so that x is multiple of 3, and we have 3, 6, 9, and so on. And this is a little bit more precise notation, but when this known set is pretty obvious, then we take abbreviate notation like that. Most of the time, the set we begin with is a set of real numbers, in this class at least. Subset, element, well, you should know about those kind of things. How about the set of numbers? These are the notations we are going to use. N, W, Z, Q, R, C. Set of natural, whole, integers, rational, real, and complex numbers. Another important sets are set of intervals, and we have semi-inequality, then we have bracket, strict inequality, we have parentheses. Let's review basic algebra this time. How to solve an equality? Well, we manipulate, but make sure everything is correctly written in terms of mathematical grammar. Here's a wrong example. 2x equal to 3 minus 1 after flipping this plus 1 to the other side. Consequently, we have negative 4. Dividing by 2, we have negative 2. So that's the answer. Is this right? Answer is correct, yes, but this is not correct expression. This equality is not right. Negative 3 minus 1 is negative 4, not negative 4 divided by 2. Negative 4 and negative 2 are two different numbers, not the same. So this is a mistake, and I will scrutinize this kind of thing. After all, mathematics is mostly communication. A lot of things go bad, and sometimes people die from it, but rarely that is because of somebody get a wrong solution. It's coming from mainly miscommunication. So communicating is important, and how to write according to correct mathematical grammar is important. And here's one example. 2x equals to negative 3 minus 1 after flipping this one. Consequently, we get negative 4. And then we just have a next line. Dividing everything by 2, we get x equals to negative 4 divided by 2. Consequently, yielding x equal to negative 2. This is correct solution. And please note that all the equalities are correct. And even more, I use comma here and period over there because this is the end. If you use period there, actually that's okay. How about parentheses? I've seen a lot of students making mistakes with parentheses. So let's see, go ahead with this example. I've seen some students opening a parentheses but do not close it. That's wrong. And then just use multiplication symbol without parentheses at all and then trying to get it right. But then again, very frequently you end up making mistake because of the silly mistake. So wrong communication yielding wrong answer or yielding correct answer of a wrong problem is common. And I will scrutinize that kind of thing. And then how about the next one? Well, if you distribute -3 around, -3 times each number, we have to have sign change in everywhere, but didn't do that. This kind of thing is usually due to skipping a step or using parentheses incorrectly. Here is correct solution. Got -3 times all those parentheses, and distributing -3 to each factor, we have -3 times x squared, -9 times x, and positive 6. Afterward, it is routine simplification. How about quadratic equation? Make sure the right-hand side is 0. If you just disregard the right-hand side, you just don't get anything. Subtracting 6 to the other side and keep the right-hand side 0, and then you can go ahead with factorization. How to factor a quadratic polynomial, quadratic trinomial is an important issue, and I'm going to leave that to students. You have to master this skill because it's going to come back over and over and over again. Let's go over to inequality. Work pretty much the same as equality except for one occasion. Whenever dividing by negative number or multiplying by negative number, you have to change the sign. Once you change the sign, and then you got something like this notation, x is greater than or equal to 4/3, which is correct for inequality notation. But I usually prefer interval notation. In that case, it's going to be generally better to change back into standard notation. Smaller number, less than or equal to x, and then less than infinity. You don't have to write less than infinity because any real number is less than infinity. But if you do write, then it's going to make it a little bit easier to convert it over to interval notation. Bracket, smaller number, comma, larger number, which is infinity actually. Against infinity, you always have parentheses because nothing is equal to infinity. Okay, that was basic algebra. How about some intermediate algebra? Some factorization formulae are here. First two are extremely important. Complete square formula. You can get it by foiling out a plus b or a minus b. Now, if they mix those two together, then I have a squared minus b squared. The other two are not really important as formulae, but those two are important as factorization techniques or skill. What do you do if you have monic quadratic trinomial? Get a factor of the constant term which add up to the middle coefficient, and that's explained by this. The fourth one is not really useful, and you'll have to use alternative technique to factor a quadratic trinomial, but I'm going to leave that to students actually. Let me warn you, you cannot simply throw away the middle number, the middle term, plus minus 2ab. That is really necessary. And things like that, square root, you can't do that. I have never seen pre-calc students doing this, but in college algebra or below, I have seen students doing this. This is not right either. You cannot separate the denominator. Okay. All right. How do you handle this kind of problem? Oh, no, that's too easy. How do you handle this kind of problem? If you have square root, then you can square both sides of the equality. Okay, why am I using wrong solution here? Square both. Oh, I see. If you break up this square root like this, then you get a crab. That's basically it. Correct solution is this. square both sides, and we have x minus 1 is equal to 2 squared, which is equal to 4, and we have a linear equation. And similar thing will go about here as well, I think. You cannot simply break up the parentheses like this. You'll have to use the complete square, or you have to use FOIL method, whatever you may want to prefer. How about some linear equation here? Okay, how about first wrong solution here? Just killing off the denominator, simply multiplying by all the denominators, but that's not right, because you have to multiply the same number to each term. Here you just multiply by different numbers. I've seen this kind of mistakes in intermediate algebra or below, but in pre-calc level, I don't think I remember seeing this kind of thing. This kind of mistakes I have. It's a silly mistake. The students remembered to multiply 12 to each term, but forgot to do that to this term. Be careful about that. And then, yes, this kind of thing I saw too. When multiplying, forgetting to distribute, and then just multiply to the first term only. Or distribute incorrectly. When you distribute -2 around, you have to multiply -2 to first term and also the second term as well. So you have to have a sign change here. Same goes over here. -3 times 2x, you have -6x, that's right. -3 times -1 is negative, positive. +3. We have a sign change, but didn't do that here and there. This kind of mistakes are rather common. And once you make this kind of stupid mistakes, it's very difficult to spot it. Bigger mistakes are easy to find. Here's the correct answer, and then the solution. Okay. Let's see. Let's talk about a little bit of advanced algebra. Expansion of factories. Okay, this is something we discussed already. Zeros and multiplicity. Once you factor these kind of numbers, these kind of powers, m1, m2, those kind of things are called multiplicity of 0, x equal to c1, x equal to c2, all the way up to x equal to ck. Those are called multiplicities. And those play a significant role solving a polynomial equation. Whenever you're solving this kind of polynomial equation, you have to set the first factor equal to 0. I mean, if you set this equal to 0, then it becomes first factor equal to 0, second factor equal to 0, all the way to k factor equal to 0. Those become zeros. And then there are multiplicities, m1, m2, m3, all the way up to mk, play a significant role because whenever you cross these zeros, you have to make decision whether to change sign or keep the same sign. The main idea is to change a sign when multiplicity is odd, keep the same sign where if the multiplicity is even. Here's an example of quadratic inequality, and here's an example of a wrong solution. If you have quadratic inequality, just factor it, just like solving an equation, and then first factor is greater than or equal to 0, second factor is greater than or equal to 0. We have these two, but those inequalities are incorrect. One of them is right, the other is wrong actually. How do you get the correct solution? Well, a times b is greater than or equal to 0 does not mean a is greater than 0 or b is greater than 0. Actually, equality, it works. For inequality, it doesn't. One is less than or is equal to 0, or one is greater than or equal to 0. How do I know? Because I have to get positive times positive, kind of like that, in this kind of situation, or negative times negative, as in this kind of situation. So we have you have union of two intervals like that, and then you can see that by looking at the graph. As you can see, left hand side, right hand side, that's when this thing is positive. Another way to see it is to use a interval argument. Here in the right hand side, when x is greater than 3/4, always positive, and all those multiplicities as 1. So as you change plus to minus, minus to plus, we have sign change. That's how we can figure this out.